The sun did not roar. It whispered. In the deep vacuum of space, where no air can carry sound, its silence was absolute, yet its presence filled everything. For 4.5 billion years, it had burned with an unbroken rhythm, a pulse older than the Earth itself. Each flare, each eruption of plasma, was a note in a symphony of continuity. The sun had always been constant, a living clock against which all life measured its fleeting existence. But lately, something in that rhythm had begun to change. In the imagery of solar telescopes, in wavelengths invisible to human eyes, a pattern emerged. Faint tremors in the corona, temperature waves pulsing not with violence but with hesitation. It was as if the sun had taken a breath and forgotten to exhale. Deep in the archives of NASA's Solar Dynamics Observatory, analysts watched data streams that refused to fit their models. The light curves rippled with irregularities, subtle at first, then undeniable. The sun was not steady. It was trembling, and then came the light. A small, cold glow from beyond Mercury's orbit, not golden, not red, but green, emerald, shifting, alive. At first it was dismissed as a sensor anomaly, a cosmic ray strike on a CCD, but the pattern repeated, consistent, rhythmic. The object was moving, not drifting like a comet, but with intent. Spectral readings showed elements not native to the solar system, an interstellar composition, metallic and fractured, a remnant of another star's death. They named it again 3I Atlas, the third known interstellar object to cross the sun's dominion. Years ago, it had disintegrated beyond Mars, leaving only dust and confusion. But now, impossibly, it has returned, not as a rock, but as a pulse. Its surface shimmered with ionized gases, its trajectory curved in defiance of gravity, and it seemed to be resonating with the sun's magnetic field, amplifying, echoing, synchronizing. Solar physicists argued in silence, staring at the spectral lines that suggested something no equation could predict, a possible interaction, a feedback between this wandering fragment of another system and the very heart of ours. Through the blackness, the sun's face shimmered, filaments coiling like nerves, flares collapsing into silence. The emerald light grew stronger. A dance began between the two, one ancient, one for an exchange that no human eye had ever seen. And as the cameras tracked the shifting corona, the narrator's voice would emerge, low, calm, heavy with wonder. For the first time in human history, something from beyond our solar system is touching the light that made us. A question hung between the stars, vast and terrifying in its simplicity. What happens when the sun responds? At first, it was only a flicker, a whisper buried in terabytes of solar telemetry. The European Space Agency's solar orbiter, drifting just inside Venus's orbit, had been staring at the sun for months, feeding humanity a constant stream of data, plasma flows, magnetic turbulence, ultraviolet flares. But then came a pattern. Every 22 minutes, a small but measurable dip in coronal brightness, rhythmic, precise, deliberate. No solar process worked with that kind of regularity. Yet the dips returned, unbroken, like the ticking of a cosmic metronome. When researchers overlaid the readings with orbital data, a coincidence became an impossibility. The rhythm matched perfectly with the trajectory of 3I Atlas. The object that should have been silent was somehow in conversation with a star. From ground-based observatories in Chile and Hawaii, telescopes confirmed a strange emerald shimmer radiating from the region around Atlas. At first glance, it resembled fluorescence, sunlight reflecting off icy minerals, but its spectral signature betrayed something more alien. The glow wasn't reflected, it was emitted. The lines corresponded to ionized oxygen, but under magnetic field strengths that could not exist outside an engineered environment. Somewhere in that fragment of stone, atoms were being rearranged in ways no natural process could sustain. Instruments designed to measure the sun's magnetism began returning erratic data. The fields near Atlas's position shifted direction, subtly, persistently, as though responding to an invisible hand. These were not flares or prominences. They were controlled inversions, small magnetic loops folding and twisting around the object, like iron filings pulled toward a moving magnet. Solar physicists hesitated to draw conclusions, but the evidence was undeniable. Atlas wasn't just interacting with the sun, it was changing in mission control rooms at NASA's Goddard Space Flight Center. At the Max Planck Institute for Solar System Research, the conversations turned from excitement to unease. "We're looking at a rock," one researcher said, "that behaves like a reactor." Others whispered that perhaps it was acting as a conduit, a bridge between magnetic domains. No one wanted to say the word machine, but it lingered unsaid in every silence. The solar orbiter's high-frequency imagers soon captured something stranger still. Around the sun's limb, ripples began to appear in the visual feed, distortions that no lens could explain. They came in soft waves, bending light as though space itself were trembling. Some called it a calibration issue, others blamed radiation interference. But the timing aligned once again with the 22-minute rhythm. Each ripple coincided with a pulse from Atlas, a faint surge of energy, like a heartbeat transmitted through the solar wind. In the scientific journals, theories began to multiply. Perhaps Atlas was absorbing high-energy plasma, draining magnetic flux from the corona. Others speculated the opposite, that it was injecting something back: energy, information, even matter, into the solar atmosphere. Whatever the truth, it defied all conventional astrophysics, and beneath the equations and simulations, a quieter dread began to grow. The sun, the symbol of constancy, the one thing that had never failed, was no longer behaving like itself. Humanity's oldest source of light now carried a pattern, a rhythm, a pulse that did not belong. The astronomers who had once spoken of our star, in familiar terms, now watched it with a new and unsettling awareness, not as a companion, but as a patient. Something foreign was touching it, changing its breath, rewriting its balance. For the first time in recorded history, the sun was no longer just shining. It was responding. The silence of deep space is an illusion. In the language of magnetic fields and particle winds, the universe speaks, a constant exchange of invisible messages written in plasma and light. For centuries, the sun's dialogue with its surroundings had been chaotic but natural. Bursts of radiation, flares, coronal mass ejections, all obeying the restless mathematics of fusion. But as the days passed after Atlas's reappearance, a new rhythm emerged, structured, deliberate. Impossible solar flare data began showing temporal echoes, tiny shifts in emission before each eruption, as if something were anticipating them. The ESA's solar orbiter and NASA's Parker solar probe, observing from separate orbits, confirmed what no algorithm could rationalize. The pulses radiating from Atlas occurred seconds before solar activity flared, not after. It was as though the object was responding to a signal that hadn't yet been sent, or worse, predicting it. Astrophysicists turned to artificial intelligence to find meaning in the noise. They fed months of plasma wave readings into machine learning models, searching for patterns beneath the chaos. What came back was unsettling. The energy intervals between Atlas's pulses followed a precise ratio, one not found in any natural oscillation known to physics. The numbers resembled prime sequence modulation, a mathematical pattern used in digital communication to ensure clarity over long distances. The implication was unnerving. The pulses were not random. They were encoded as attention turned toward the object itself. High-resolution imagery revealed that Atlas was not the smooth, tumbling fragment once catalogued by early telescopes. Its surface was irregular, oblong, fractured, and covered in deep geometric scars. Those fractures weren't inert. They glowed. Spectral analysis showed the light was coherent, similar to laser emission, focused, consistent, and synchronized with the solar pulses. Each crack seemed to act as a channel, guiding energy outward in rhythmic intervals. No one wanted to be the first to say it, but eventually the term began circulating quietly among researchers. The living machine hypothesis. What if Atlas wasn't debris at all? What if it was designed, a construct that had crossed interstellar space, not by accident, but by intention? Its behavior mirrored neither asteroid nor comet. It was reactive, even adaptive, aligning itself with the sun's magnetic fields as if feeding on them. Some imagined it as a dormant technology, awakened by proximity to a star's radiation. Others believed it might be a relic, a surviving remnant of an extinct civilization, programmed to seek energy from suns it encountered. The public, however, did not wait for caution. Once the first leaked images hit the internet, speculation turned feverish. Commentators spoke of alien probes, cosmic reactors, even harbingers of solar manipulation. NASA urged restraint, describing the findings as under investigation. But inside scientific circles, the tone had changed. For the first time, the word construct appeared in official logs. And then the sun itself began to respond. Minute variations appeared in its luminosity, barely a fraction of a percent, yet large enough to trigger anomalies in satellite readings. To the naked eye, nothing seemed different. But to instruments that had measured the sun's constancy for decades, the change was unmistakable. Something was altering the solar output. Perhaps it was only a coincidence. Perhaps Atlas's arrival and the dimming were unrelated artifacts of observation or chance. Yet the timing, the precise, elegant timing, refused to be ignored. Each fluctuation in solar brightness corresponded to the pulse from Atlas, a pattern that held through every rotation of the star dot in observatories across the world. Screens flickered with data that carried both beauty and dread. The sun, once a silent giver of warmth, now seemed to be engaged in conversation, not with its planets, not with human observers, but with something born of another system entirely. As the nights deepened on Earth, a quiet understanding began to settle among those who had seen the data. The sun, the oldest constant in human life, was no longer alone in its power. If Atlas could influence a star, then it was not merely a visitor passing through our solar system. It was a participant reshaping the very light that defines existence. Teams from the European Space Agency, NASA, and the Max Planck Institute assembled emergency working groups. Data pipelines were rechecked, instrument calibrations verified, and cross-spectral comparisons performed across multiple wavelengths: radio, visible, ultraviolet, and X-ray. Every effort sought a mundane explanation, a statistical artifact, a computational misread. None appeared. The synchronization between Atlas's emissions and solar activity persisted with clock-like precision. When the sun released a flare, the object had already registered a pulse seconds before. The predictive correlation exceeded 0.98, far beyond coincidence. At NASA's Goddard Space Flight Center, analysts began constructing a comparative model of magnetic field coupling. Using magnetohydrodynamic simulations, they tested whether a dense metallic body moving through the solar wind could induce field alignment strong enough to influence flare timing. The results were inconclusive to achieve the observed effects. Atlas would require an internal magnetic field millions of times stronger than that of Earth, something no known natural process could produce within an object of its size. Further, analysis from the Parker Solar Probe revealed an even stranger detail. The plasma temperature around Atlas was lower than surrounding regions, yet the density of charged particles was higher. Normally, energy disperses outward from hot to cold. Here it appeared to reverse, as if Atlas was siphoning energy, reorganizing it, and emitting it in structured intervals. The emissions formed coherent wavefronts, narrow and symmetrical, extending hundreds of kilometers before fading into the solar wind. A joint paper drafted by an international research consortium proposed that Atlas might be operating as a magnetic oscillator, a self-stabilizing resonant body, converting solar energy into organized fields. The authors stopped short of labeling it artificial, but admitted the phenomenon resembled engineered plasma control. Reviewers rejected the submission for lack of causal proof, yet off-record discussions continued. Several physicists pointed out that the energy-frequency ratios mirrored those used in advanced fusion experiments designed to stabilize plasma confinement. As data accumulated, a new issue emerged. The Sun's global magnetic field, typically reversing polarity in predictable 11-year cycles, began to show premature oscillations. Small deviations first appeared near the equatorial belts, then propagated toward the poles. Satellite measurements detected regional polarity inversions weeks earlier than any model predicted. Some researchers speculated that the interference might accelerate the solar cycle entirely, potentially altering patterns of sunspot formation and solar radiation output for decades. Outside the scientific community, the impact grew rapidly. Market data showed rising fluctuations in space weather-sensitive sectors. Satellite operators reported abnormal charging events. Several communication arrays temporarily lost signal coherence during the Atlas pulse windows. Governments issued quiet advisories to power grid operators under the pretext of geomagnetic unpredictability. Official press releases avoided the object's name, but internal documents acknowledged a single external variable correlated to the anomalies. Within months, an international observing campaign was launched under the coordination of the United Nations Office for Outer Space Affairs. The goal was continuous monitoring of Atlas from multiple angles: optical, infrared. Data streamed constantly from ground-based and orbital instruments, building the largest dataset in solar observation history. Yet for all the effort, the underlying question remained unresolved. Atlas's pulse cycle remained steady, 22 minutes, unwavering. Each emission carried a complex frequency spread, repeating in precise intervals that suggested purpose. No random system maintains such stability over time, especially under the intense turbulence of the solar environment. The object appeared to adjust dynamically, compensating for solar wind pressure and magnetic drag, maintaining its position as if locked to an invisible coordinate. What concerned researchers most was not the light it emitted, but the faint feedback visible in the Sun's behavior. Minute changes in coronal density began to follow Atlas's cycle. The corona brightened and dimmed at the same rhythm, forming standing wave patterns never before recorded. Energy seemed to flow between the Sun and the object in both directions, a feedback loop that no existing solar model could describe. In private conferences, astrophysicists debated what such interaction could mean for the long-term stability of the Sun, if Atlas was transferring or redistributing magnetic energy. Even at small scales, it could alter solar convection processes over time. Yet predicting the outcome was impossible. The system had no precedent. A star and a foreign interstellar object locked in measurable exchange, no theory satisfies both observation and physics. Some saw Atlas as a reactive mineral body exploiting natural magnetic resonance. Others suspected active modulation, controlled feedback, the hallmark of a functioning mechanism. With every orbit, the line between natural and artificial blurred further, and so the monitoring continued, silent, continuous, and tense. The sun's surface flickered with unfamiliar precision. The green pulses persisted, and in every laboratory and control center, screens glowed with patterns no one could yet interpret. The data spoke clearly. Atlas was not a passive traveler. It was engaging. It began, as many cosmic mysteries do, with a misinterpretation. In the early months of 2020, astronomers at Mauna Loa and Haleokleb recorded the faint emerald smear of what appeared to be an ordinary comet. It was catalogued quickly. C 2019, a visitor from the outer reaches of our solar system, breaking apart as it drew near the sun. For weeks, observatories around the world watched its glowing fragments disperse across millions of kilometers. To every instrument, every model, it looked terminal, a dying body collapsing under the heat of its parent star. By April of that year, it was declared gone. The story should have ended there. But years later, a different story began to emerge. A team re-examining early observation data noticed subtle deviations in the comet's brightness before its supposed disintegration. The luminosity curves did not match the decayed pattern of a fragmenting nucleus. Instead, they displayed intermittent energy surges, as if the object was stabilizing, not breaking apart. The archival frames, once dismissed as sensor error, revealed small but measurable shifts in its velocity. The object had accelerated, not toward the sun, as gravitational models demanded, but away from it. In the physics of celestial mechanics, such behavior should be impossible. Comets can outgas, releasing jets of vapor that push them slightly off course, but not enough to reverse acceleration. The change in trajectory recorded in 2020 defied every known natural explanation. Newton's laws could predict where it should have fallen. Instead, it left those predictions behind. When the data was first reported, it was ignored. The world at that time was focused elsewhere. Humanity's gaze turned inward, consumed by crisis. The unexplained anomalies from a faint comet were an afterthought, buried in digital archives, unreviewed for years. Only when 3I Atlas reappeared near the sun did researchers begin to look again. What they found in those old files no longer looked like coincidence. Overlaying its 2020 trajectory with the path it now followed revealed something extraordinary. The vectors aligned with mathematical precision, as though pre-calculated, each phase intersecting the sun at the same relative orientation. Such geometric regularity suggested intent, or at least a level of control, unknown in natural orbital mechanics. Some began to wonder if Atlas's disappearance had been misread entirely. Perhaps what seemed like destruction had been transformation. Comparisons with previous interstellar visitors only deepened the mystery. Oumuamua, the first known interstellar object, had baffled scientists in 2017 with its non-gravitational acceleration. 2 years later, 2I Borisov arrived. An ordinary comet, by all accounts, natural and predictable. Atlas, however, refused classification. It behaved like neither. Where Oumuamua tumbled silently through space, Atlas pulsed. Where Borisov evaporated in sunlight, Atlas seemed to feed on it. Astrophysicists debated the implications quietly, aware of how fragile the evidence was. But patterns in cosmic behavior have a way of repeating. The odds that 3 interstellar objects would all exhibit anomalous dynamics within a single, decade-strained probability beyond reason. Something about these encounters suggested that interstellar space might not be as empty. or as random as once thought. When Atlas reappeared, its orbit carried it along an arc that placed it once more within influence of the Sun. The curve of its return mirrored the path of its departure, as if following a hidden circuit, a closed loop of its own design. To some, it resembled a navigational path, a recurring cycle defined not by chance but by function. The possibility that it might be part of a larger network, fragments or probes tracing long-period routes between stars began to surface in speculative circles. Within this speculation lay an unease that reached beyond science. The Sun, long considered the unmoving center of human understanding, had become a node in something larger, a participant in an interaction. Humanity did not initiate in the dim light of observation rooms. As astronomers compared decades of sky maps, one question surfaced repeatedly. If Atlas had altered its course once, if it had defied destruction and returned after years of silence, then perhaps the most unsettling explanation was also the simplest. Maybe Atlas had never left. Maybe it had been here all along, hidden in the vast geometry of light and orbit, waiting for the moment when humanity would look closely enough to notice. As the data accumulated, the scientific response began to shift from disbelief to careful analysis. NASA's Jet Propulsion Laboratory coordinated with ESA and the National Solar Observatory to reconstruct Atlas's trajectory using all available archival sources: optical, infrared, and radio. The reconstructed flight path revealed multiple course corrections that could not be explained by known cometary forces. Each change occurred with a measurable timing pattern, as if responding to external gravitational fields. But no nearby planetary body accounted for it. Thermal models also failed to fit the evidence. Normally, when a comet approaches the Sun, sublimation of ice generates jets that produce uneven but predictable thrust. Yet Atlas's rotation period remained constant, showing no torque variation consistent with such out. This consistency implied a rigid structure, more metallic than icy. Spectrographic analysis of its tail, originally thought to be vaporized water, contained faint but distinct traces of nickel, iron, and silicate compounds in ratios uncommon to natural comets. The reflectivity index aligned more closely with engineered alloys than with carbon-rich rock. These findings prompted the first formal anomaly report under the International Astronomical Union's Interstellar Object Watch program. A panel convened to review the evidence concluded that Atlas's physical behavior and spectral data did not conform to any known natural category. The report stopped short of suggesting artificial origin, but it noted unidentified non-gravitational accelerations consistent with directed motion. Meanwhile, the Deep Space Network detected faint electromagnetic emissions in the same frequency range as solar radio noise. Coinciding with Atlas's perihelion approach, the signals were modulated, repeating at regular intervals that followed a mathematical ratio to 11:7, repeating over several days. This ratio matched the pulse spacing observed in the 2025 data linking Atlas's emissions to solar flare cycles. AI models trained on the emission data began to find coherence where humans had seen randomness. The modulation displayed nested harmonics, a pattern suggestive of intentional encoding. However, decoding attempts produced no recognizable format, leaving only speculation. Could the emissions represent data transmission, navigation telemetry, or something entirely unknown? Parallel to the scientific inquiry, archived observation data from 2020 revealed another overlooked clue. Just before its supposed breakup, Atlas had shifted to a high-inclination orbit that intersected the solar magnetic equator at an angle consistent with field-aligned motion. Such alignment indicated not a passive trajectory, but a possible interaction with the Sun's magnetic architecture. The object appeared to use the heliospheric current sheet, the massive wave-like surface, extending outward from the Sun, as a guide. This behavior suggested that Atlas was navigating magnetically, a mechanism not observed in any known celestial body. When these findings reached the astrophysical community, they reignited comparisons to theoretical propulsion methods like magnetic sail technology, concepts where an object could maneuver by interacting with solar, wind, or magnetic fields. If Atlas was somehow manipulating its position using magnetic resonance, it would imply a control system with precision far beyond human engineering. By mid-2025, several observatories confirmed that Atlas was again approaching the Sun, following a trajectory that would take it within 0.23 astronomical units, a region intensely hostile to any conventional material. Yet its surface brightness remained stable. Infrared measurements indicated no increase in temperature. This suggested either an unknown heat dissipation mechanism or a composition capable of reflecting and absorbing solar energy in ways unachievable by current materials science. At this stage, the debate split into two camps. The first maintained that Atlas was an unusually coherent fragment of an interstellar object, a geological rarity with unknown composition but natural origins. The second argued that its repeated accelerations, geometric shape, and emission patterns required active control. Both agreed on one point: Atlas did not behave like a comet. The re-examination of its 2020 detection period also exposed the limits of early instrumentation. Atmospheric interference, limited exposure times, and calibration errors had produced what many assumed were visual artifacts. Now, with modern processing, those same frames showed lattice-like structures across Atlas's surface, faint, repeating lines resembling polygonal networks. These were not cracks from impact or heat stress. They were symmetrical, consistent in spacing, and aligned along its longitudinal axis. This revelation forced another uncomfortable reassessment. If the object's geometry was deliberate, then its return could not be random. The timing of its reappearance, synchronized with a new cycle of solar activity, hinted at a larger pattern. It seemed to arrive precisely when the Sun entered its peak magnetic phase, as though drawn to the rising energy of the solar maximum by late analysis. The conclusion, emerging across multiple institutions, was cautious but firm. 3I Atlas could no longer be described as a typical interstellar body. It had demonstrated repeatable, measurable interactions with the Sun's field and emitted signals consistent with patterned modulation. In practical terms, these findings changed the nature of the investigation. Atlas was no longer treated as a transient curiosity, but as an active variable within solar observation models. Dedicated instruments were recalibrated to monitor its every movement, every pulse of radiation. Its presence had become a parameter in solar forecasting, a line of data as critical as sunspots or coronal mass ejections. The question of what Atlas was: debris, probe, or mechanism remained open. But one fact was becoming unavoidable. Whatever it represented, it was not behaving independently of the Sun. Its actions, its reappearance, and its timing all pointed toward a relationship, a deliberate alignment with the star that gave it life or purpose. And so, the record of 2020 no longer marked an end. It marked the beginning of recognition, the moment humanity first encountered something that not only defied destruction, but seemed to understand the forces that destroy across the scientific world. The revelation of Atlas's behavior began to fracture what had always been a united pursuit: truth through evidence. In conference halls and digital symposiums, the first schism emerged. a quiet but widening fault line between those who saw Atlas as a natural enigma and those who whispered the possibility of intelligence. One camp held tightly to the laws of physics, determined that even the impossible must obey them. The other saw, in Atlas's patterns, something that laws alone could not explain: design, purpose, or at least intent. The debate was no longer academic. It had become personal. Papers were withdrawn before publication. Funding requests were stalled without reason. Inside NASA and ESA, internal memos began to circulate, warning against premature speculation. Researchers found themselves bound not by evidence, but by institutional caution. History had seen this before: the silencing of discovery until its implications could be politically contained. And yet, this time, the object in question was not on Earth, but orbiting the Sun, communicating in the language of plasma and light. Behind sealed doors, security divisions classified segments of Atlas telemetry. The justification was familiar: national interest, public stability, data integrity. But the subtext was clear: humanity was not ready. Some scientists complied, others rebelled. Leaked images of Atlas's magnetic emissions spread online within hours, dissected by amateur astronomers who saw patterns that official reports refused to acknowledge. A rhythmic signal repeating every 22 minutes, perfectly synchronized with solar flares. Some called it coincidence, others called it dialogue. For those closest to the data, the experience grew heavier with each passing day. The Solar Observation Network, a collaboration of physicists and computational analysts, became the emotional front line of this crisis. Long hours spent staring at magnetic field graphs and solar telemetry began to take their toll. Several described the patterns as responsive, as if Atlas were reacting to observation. When they altered their imaging frequency, the emissions changed slightly in return. A few called it feedback. Others, privately, called it awareness. Within these rooms, the air grew tense. What if Atlas was not simply being studied, but was studying them back? The thought hovered over every analysis, unspoken but inescapable. Some dismissed it as projection, the human tendency to find meaning in noise. Yet others noticed too many coincidences to ignore. Data clusters appeared minutes after human intervention, mirroring the changes they made. It felt less like data gathering and more like a silent exchange, one neither side had initiated. At the institutional level, ethical discussions surfaced. Could the scientific method apply to something potentially conscious? Observation, by its nature, alters the observed, a principle proven in quantum mechanics, but now bleeding into the macroscopic. If Atlas were more than an object, if it were a system, or signal, or awareness, then every scan, every radar pulse, might count as interference. For the first time in astrophysical history, humanity faced the possibility that studying the universe might not be a neutral act. Outside the laboratories, the world began to react. Religious organizations declared Atlas a celestial messenger, a harbinger of divine correction. Some saw its orbit as a cosmic sign, aligning with ancient prophecies about a star of judgment. Social media exploded with theories that Atlas was a probe, a weapon, a mechanism of balance. Conspiracies thrived in the gaps between official statements. The more authorities withheld, the faster speculation filled the void. Humanity, it seemed, could not tolerate silence in the face of the unknown. Governments met in private councils. For every public denial, there were quiet preparations. Monitoring networks expanded, solar warning systems upgraded, classified briefings held beneath layers of bureaucracy. What had begun as a scientific question was rapidly evolving into a geopolitical one. Who would own the discovery? Who would interpret it? Who would decide what humanity should know? Amid the growing noise, the lead investigator of the Solar Observation Network, Dr. Alina Varga, resigned. In her final internal statement, she wrote, "We are witnessing physics that feels personal." The phrase circulated across research channels, quoted by some, dismissed by others. But it captured the unease that had taken root in every observatory, that the universe was no longer indifferent. After Varga's resignation, an unofficial freeze settled over the investigation. Public data streams slowed to a trickle. The AI models that once processed Atlas's emissions were quietly repurposed. It was as if the world had agreed, silently, to look away. But in the background, Atlas continued to pulse, its emissions steady, rhythmic, alive. Each burst echoed through the heliosphere like a breath from something vast and waiting. And so, the mystery turned inward. The question was no longer what Atlas was, but what it revealed about humanity itself. Faced with knowledge that defied comprehension, the collective response was not unity, but fracture. Science became belief, data became faith, and discovery became conflict. For centuries, humanity had looked to the stars to understand creation. Now, under the steady pulse of a green, interstellar light, it began to wonder whether creation was finally looking back. In the months that followed Dr. Varga's resignation, the investigation shifted from open collaboration to compartmentalized research. Access to Atlas data became restricted to a handful of approved institutions, each working in isolation. The Solar Observation Network, once a global cooperative, fractured into competing divisions. Some operated under civilian mandates, others under military contracts. The data pipeline that once flowed freely across nations was rerouted through security channels. What had begun as scientific transparency had now transformed into strategic containment. Researchers who remained on the project were instructed to focus solely on measurable phenomena, plasma readings, magnetic field strength, spectral emissions, and to avoid unsubstantiated correlations. Yet even in that narrow framework, inconsistencies persisted. Atlas's emissions did not behave like natural solar echoes. They were modulated, structured, and temporally aligned with solar activity. It was as if Atlas had established a synchronization routine, adapting to the sun's cycles. Theoretical physicists proposed resonance coupling, a feedback mechanism through which Atlas could be harvesting or redistributing solar energy. Others rejected this interpretation, insisting the readings were artifacts of interference or software error. To test these possibilities, new instruments were deployed aboard the Parker Solar Probe and ESA's Solar Orbiter. These probes, operating closer to the Sun than any before, captured electromagnetic fluctuations, matching the same periodic signature associated with Atlas. Cross-referencing, data confirmed the source, the object itself. Each cycle produced a measurable distortion in the heliospheric current sheet, the vast surface dividing the Sun's magnetic hemispheres. The implications were serious. Atlas appeared capable of influencing large-scale solar structures, albeit minimally. It was not enough to alter the Sun's overall stability, but it demonstrated interaction, an active presence within the solar environment. The findings reignited division. Within NASA's Heliophysics Division, several scientists argued for a public disclosure, reasoning that the discovery represented a natural but unprecedented form of solar interaction. Others, under pressure from policy advisors, advocated silence until a definitive explanation could be produced. The hesitation stemmed not only from fear of public reaction, but from the lack of a coherent theoretical framework. Physics had no precedent for an interstellar object capable of electromagnetic feedback with a star. Without that, speculation risked undermining institutional credibility. At the same time, Private research groups began independent monitoring using ground-based observatories. The data they released online showed Atlas emitting faint bursts in the visible and near-infrared spectrum. These bursts correlated with transient decreases in solar wind velocity, localized and short-lived, but consistent. The pattern persisted for weeks. The data, once dismissed as coincidence, began to accumulate into a statistical signal. It became clear that Atlas was not passive debris. It was participating in a dynamic system. This realization intensified tensions among leadership. Strategic analysts considered potential risks. If Atlas could influence the Sun's magnetic balance, even marginally, the consequences were unpredictable. A small shift in solar output could affect radiation levels, satellite electronics, or even climate conditions. Though the effects were theoretical, contingency planning quietly began. Classified reports modeled possible outcomes ranging from negligible to severe. None could fully account for the unknown nature of Atlas's mechanisms. Publicly, communications from major agencies adopted a neutral tone. Press statements described Atlas as an unusual but natural interstellar object under continued study. The language was careful, deliberately vague. Internally, however, working groups debated the deeper question: was this phenomenon reproducible or unique? If Atlas was the first of its kind, it might represent a rare event in interstellar physics. If not, it could be the initial contact with a recurring process, something designed to interact with stellar systems at predictable intervals. Meanwhile, in the background, the object's trajectory continued to shift. New orbital data indicated minute course adjustments inconsistent with gravitational prediction. These corrections were subtle but measurable, as if Atlas were maintaining an equilibrium point relative to the Sun's magnetic field. Computer simulations failed to explain how an inert mass could sustain such stability without propulsion. It remained precisely within a magnetic corridor, riding fluctuations with precision comparable to active control. By this stage, the tone within research documentation had changed. Reports once written with curiosity now carried cautious detachment. Words like communication, interaction, and response were replaced with correlation, coupling, and feedback. The avoidance of anthropomorphic language was deliberate, meant to preserve objectivity. Yet the pattern of evidence continued to grow, pointing toward a system exhibiting adaptive properties. The discomfort lay not in the data itself, but in what it implied about agency. Psychological assessments were quietly introduced for the research teams. Long exposure to the data streams had produced fatigue, insomnia, and recurring anxiety among analysts. Some described recurring dreams of light pulses and solar waves. Administrators attributed these symptoms to overwork and confirmation bias, but off-record interviews revealed a shared unease, the sense that the data's behavior felt coordinated, almost responsive to observation schedules. As months passed, the social dimension of the mystery deepened. Media outlets alternated between skepticism and alarm. Leaked internal documents appeared on public forums, fueling conspiracy claims. Public interest surged. Online groups analyzed telemetry, some producing near-accurate reconstructions of Atlas's modulation patterns. When government representatives were asked for comment, they declined, citing national research security. The silence only amplified suspicion. Inside observatories, a quiet consensus began to form that the search for a definitive answer might never yield a single result. Atlas was both anomaly and mirror, an event revealing as much about human interpretation as it did about physics. The effort to define it had exposed the limits of current science and the fragility of scientific unity. The data stood unaltered, factual and indifferent. The conflict existed not in the numbers, but in human response. By the time the next solar rotation completed, Atlas's signal stabilized into a consistent pulse every 22 minutes, unwavering. No further trajectory changes were detected. The object remained fixed in its position, balanced between solar gravity and magnetic tension. Whatever its purpose, it appeared content in its orbit. Scientists continued to monitor, theorize, and debate, but the sense of control had faded. Humanity had become an observer again, watching something vast, complex, and silent, operating according to rules not yet understood. The conflict that had begun with discovery ended not in resolution, but in restraint. The world had learned that some knowledge resists interpretation, that not every anomaly demands immediate explanation. Atlas remained what it had always been, an object in space, pulsing against the sun's light, indifferent to human argument, consistent in its mystery. In the months following the first official acknowledgement of Atlas's electromagnetic synchronization, a coordinated investigation began. Data from NASA's Parker Solar Probe, the ESA's Solar Orbiter, and Japan's Hinode mission were compiled into a unified telemetry network, the most complex solar data merge ever attempted. What emerged was neither static nor chaotic, but structured. Every 22 minutes, a surge of electromagnetic flux rippled outward from Atlas, intersecting the sun's magnetic field lines with mathematical precision. It was not random radiation, it was rhythmic. Each pulse corresponded to a momentary reconfiguration in the solar corona. Subtle yet measurable, a harmonic resonance between an interstellar object and the sun itself. The first question was thermal. At its current distance, any known object would disintegrate. The solar intensity, exceeding hundreds of kilowatts per square meter, should vaporize rock and metal alike. Yet Atlas remained intact, even stable. Thermal imaging from Parker's fields suite registered a surface temperature cooler than Venus, an impossibility without active regulation. Some form of energy dissipation or field containment was preventing direct solar heating. When the data was cross-referenced with magnetometer readings, a pattern appeared. Atlas was surrounded by a toroidal magnetic structure, a self-sustaining envelope resembling a plasma containment field. It was not only surviving near the sun, it was adapting to it. This discovery reshaped the investigation. Plasma physicists began constructing analogues in controlled laboratory conditions. Using particle accelerators and fusion simulators, they attempted to recreate the observed emission ratios, the precise wavelength of Atlas's green glow, the pulse duration, and the measured decay of its field harmonics. Every experiment failed. No configuration of magnetic confinement, plasma density, or ionized gas reproduced the phenomenon. The equations suggested that Atlas's field stability required a feedback system capable of quantum-level synchronization, something beyond human engineering. Attention turned to quantum phenomena. Some researchers proposed that Atlas might be exploiting quantum coherence, the alignment of wave functions across an energy field to maintain internal equilibrium. If true, this would mean Atlas was not resisting the sun's radiation, but using it. The sun's photons, bombarding the object, could be serving as inputs in a coherent quantum network, processing energy the way a computer processes information. The surface glow, then, would not be mere emission, it would be computation, visible as light. Such an idea was deeply controversial. Quantum coherence on macroscopic scales remains unstable even in laboratory conditions. Decoherence, the collapse of quantum order due to environmental interference, destroys any coherence beyond microscopic systems. Yet Atlas appeared to maintain coherence, not in isolation, but in one of the most chaotic environments imaginable, the the solar corona. For this to occur naturally, it would require a material or geometry capable of channeling radiation without entropy. Theoretical models invoked exotic states of matter, metallic hydrogen, lattice, quark-degenerate shells, or materials of unknown atomic structure. None were confirmed, and all were beyond current technological replication. As investigations deepened, new inconsistencies emerged. The electromagnetic field around Atlas did not follow the inverse square decay expected of radiating sources. Instead, the field intensity dropped sharply within a specific boundary, then plateaued, a pattern identical to a controlled containment field. Moreover, the modulation rate of Atlas's glow showed minute variations synchronized with solar wind velocity. When the solar wind accelerated, the pulse frequency compensated, as though the object was stabilizing against external pressure. No inert body could exhibit such regulation. These results triggered a reassessment of its trajectory. Earlier estimates placed Atlas in a slow decaying orbit near perihelion, doomed to spiral into the Sun. But higher resolution tracking from the Solar Terrestrial Relations Observatory revealed subtle velocity adjustments, consistent with magnetic propulsion, not thrust, but field interaction. Atlas appeared to be maintaining position, hovering within a dynamic equilibrium of solar forces. It was balancing gravity, magnetism, and radiation in perfect symmetry, behavior more akin to control than coincidence. Attempts to simulate this balance computationally consumed supercomputer arrays across several institutions. Each model collapsed under the same constraint: energy imbalance. For Atlas's stability to persist, it must either generate energy internally or draw it directly from the Sun without absorption loss. This violated the conservation of energy unless the process involved quantum entanglement or zero-point fluctuations, mechanisms that exist theoretically but remain unproven. At macroscopic scales, if Atlas utilized these processes, it would represent a technology far beyond known physics. Within the investigation teams, the tone grew cautious. Words like object and comet were gradually replaced with system and entity. The shift was not philosophical but practical. Existing definitions no longer fit. Despite the mounting evidence, no one dared to declare Atlas artificial. The burden of proof remained unreachable. Yet, in closed discussions, one hypothesis began circulating quietly: that Atlas was not merely interacting with the Sun, it was influencing it deliberately. Then came an unexpected observation. Over a span of 8 solar rotations, the frequency of coronal mass ejections near Atlas's position declined by nearly 20%. Energy outbursts that once occurred regularly had subsided, their timing subtly altered. The solar atmosphere around Atlas appeared calmer, its magnetic turbulence reduced. The pattern was undeniable but unexplained. No known natural object could suppress solar activity. For a time, silence filled the research channels, the kind born not of certainty, but disbelief. This led to an unspoken question among analysts reviewing the data in dim laboratories around the world. If Atlas was not breaking the Sun, what if it was stabilizing it? It was a thought many refused to articulate. To suggest an interstellar body was repairing a star was to invite speculation far outside accepted science. Yet the data offered no contradiction. Every pulse, every magnetic adjustment, every cooling signature, all pointed toward one direction: balance. Atlas's actions did not mirror destruction. They mirrored regulation in classified internal notes. One researcher summarized the dilemma: we are witnessing a system that behaves as if designed to maintain solar harmony. Either this is the most improbable natural phenomenon in the history of physics, or we are observing engineering on a cosmic scale. Atlas continued to orbit in silence, its green pulse steady and unwavering, each rhythm marking the passage of an impossible logic, one that seemed, at least for now, to be keeping the sun in equilibrium. Following the publication of the preliminary findings, multiple research teams attempted to validate the Parker probe's readings through independent datasets. Instruments aboard the solar orbiter confirmed the synchronization patterns, but also revealed secondary harmonics, faint electromagnetic ripples occurring milliseconds after the main Atlas pulses. These ripples were not aligned with solar output, but with the probe's own telemetry intervals, as though Atlas was responding to the instruments themselves. The signals were subtle, yet statistically significant, forcing engineers to consider the possibility that Atlas was aware of electromagnetic interference and compensating for it in real time. Further analysis focused on the toroidal field surrounding the object. Using magnetohydrodynamic modeling, physicists determined that the field geometry exhibited stability points consistent with active modulation. In simple terms, Atlas seemed to adjust its own magnetic confinement, maintaining equilibrium within constantly shifting solar conditions. This control would require continuous monitoring of plasma density and magnetic flux, the kind of self-regulation seen only in living systems or adaptive artificial constructs. However, no mechanism, aperture, or emission signature matched any known form of thruster, antenna, or computing structure. The field's precision was undeniable, yet its origin remained invisible. Laboratories attempted to reverse engineer these readings by simulating equivalent toroidal fields through plasma coils and high-density magnetic chambers. Even with advanced containment and energy inputs, the results were unstable. Plasma instabilities triggered collapses within seconds, far short of Atlas's continuous operations spanning months. The implication was clear. Atlas's confinement was either based on an unknown, stabilizing medium or used principles of field interaction beyond classical electromagnetism. When modeling teams incorporated hypothetical parameters, such as localized quantum coherence or field self-coupling, stability improved mathematically. But the resulting systems demanded energy densities orders of magnitude beyond nuclear fusion at the same time. Radiative spectrometry detected no excess heat dispersion from Atlas. The emission spectrum remained narrow, centered around the green band associated with ionized oxygen and exotic plasma transitions. Yet no surrounding debris or gas cloud indicated typical outgassing or vapor loss. The object was operating as a closed system, perfectly conserving mass and energy despite the overwhelming solar flux. Some specialists proposed that Atlas might be transforming incoming radiation into structured electromagnetic output, effectively converting energy states rather than absorbing or reflecting them. This hypothesis placed Atlas closer to an energy processor than a passive body. As more data accumulated, the theoretical landscape shifted toward hybrid models. One proposition described Atlas as a self-sustaining quantum field construct, a physical structure maintaining coherence through continuous feedback between its magnetic and radiative systems. The model assumed an internal lattice composed of superconductive material capable of sustaining quantum resonance at macroscopic scales. Another, more conservative hypothesis suggested Atlas was a natural quasicrystal, or condensed plasma knot, an extremely rare configuration formed through electromagnetic cells. However, calculations of formation probability yielded numbers so low that the event was effectively impossible under known astrophysical conditions. The debates within the astrophysics community grew intense. Some researchers pushed for the inclusion of Atlas data into standard heliophysics models, arguing it could enhance understanding of coronal stability. Others refused, citing a lack of causal explanation. Peer review cycles slowed, with most results withheld pending independent verification. The classified branch of the investigation, managed jointly by multiple space agencies, began restricting access to raw datasets due to unexplained interference patterns detected in several communication bands. This interference coincided with the timing of Atlas's pulse cycles. Telemetry systems experienced transient data gaps, short synchronized disruptions in signal integrity. Engineers eventually correlated these gaps with electromagnetic phase inversions detected near the Sun's equatorial magnetic current sheet. It was as if Atlas's activity was temporarily altering the propagation characteristics of space between the Sun and Earth. No signal loss was permanent, but the periodic distortions hinted at a direct interaction between Atlas's field and the heliospheric medium. Efforts to visualize the field topology using polarized imaging yielded unexpected clarity. Instead of random plasma turbulence, researchers observed coherent alignment of charged particles within several hundred kilometers around Atlas. The pattern resembled controlled confinement, ordered flow rather than natural diffusion. This was the first visual confirmation that the magnetic field surrounding the object was influencing the solar plasma environment in an organized manner. That organization, in turn, affected the local coronal temperature gradient, slightly reducing it relative to nearby regions. In scientific terms, Atlas appeared to be conducting an ongoing process of magnetic and thermal regulation. Whether this was a natural feedback loop or deliberate function could not be determined, but the outcome was measurable: localized stabilization of solar plasma dynamics. The effect was small on a stellar scale, yet persistent enough to alter solar wind density near the object's orbit. When computational teams extrapolated these conditions forward, they noted a striking trend. If Atlas maintained this level of field stability for several years, it could theoretically reduce the frequency of coronal mass ejections along its trajectory corridor. The correlation between Atlas's presence and decreased flare activity had already been noted. Now, the modeling suggested it was not coincidence, but causation. This conclusion marked a turning point in the investigation. The idea that Atlas might be performing an active regulatory function, whether biological, mechanical, or naturally emergent, became a legitimate topic of discussion. For the first time, a question once whispered among researchers entered formal analysis logs. Could Atlas be an operational system designed to maintain stellar equilibrium? The data remained inconclusive, but no one could disprove the pattern. Every attempt to dismiss the phenomenon as coincidence collapsed under further observation. As the Sun continued its rotation, Atlas held position, maintaining its impossible temperature and unbroken pulse, a signal of unknown intent. Performing a function no known object should be capable of suspending energy, physicists gathered around simulation models that refused to settle. Every time the input parameters stabilized, Atlas's emissions would shift subtly, almost playfully, as though adjusting in anticipation. The object's pulse intervals began to correlate with solar flare decay rates. Each time the Sun released a coronal ejection, Atlas's electromagnetic field brightened, counterbalancing the solar discharge with a precise phase inversion, dispersing energy instead of absorbing it. What was once considered coincidence now formed a consistent rhythm, a conversation between star and stone. This emerging pattern gave birth to what became known as the energy transfer hypothesis. In simplest terms, Atlas appeared to be redistributing stellar plasma, acting as a stabilizer within the solar environment. Data from the Parker Solar Probe and the Solar Dynamics Observatories supported this interpretation, showing minor but measurable reductions in flare intensity following Atlas's closest transits. The phenomenon challenged the fundamental understanding of thermonuclear equilibrium, implying that an external agent could regulate stellar output. If accurate, it meant the sun, the ultimate chaotic reactor, was no longer alone in governing its own balance. Then came an even stranger realization. The sun was responding. Weeks after Atlas's field activity peaked, solar magnetographs began showing synchronized oscillations, pulse waves echoing Atlas's own frequency. It was as though the sun had entered feedback with the object, adjusting its own fields to maintain equilibrium. For the first time in modern astrophysics, an external body appeared to have initiated a two-way interaction with a star. The phenomenon was dubbed solar feedback looping, an unprecedented exchange of energy and information across plasma and magnetism. To explain such a mechanism, theoretical models turned toward extremes. Some researchers invoked the notion of advanced plasma resonance control, a technology that could manipulate magnetic harmonics at the quantum level, allowing controlled coupling with stellar dynamics. Others, less constrained by conventional frameworks, began to describe Atlas in terms of evolutionary plasma, a self-organizing, energy-adaptive entity operating through principles of quantum coherence. The idea was dismissed in official channels, but it lingered, quietly gaining momentum as evidence mounted that Atlas's emissions were structured, not random, not noise, but information. Speculative astrophysicists proposed what became known as the Dyson seed theory. If the sun were part of a larger network, a galactic ecosystem of energy-regulating nodes, then Atlas might represent one of its smallest components, a self-replicating fragment designed to harvest, balance, or seed stellar energy. It was not the scale of a Dyson sphere, but the essence of its principal control through distributed intelligence. Such a system would not build around a star. It would merge with it, integrating across electromagnetic fields rather than physical structures. Quantum physicists, searching for underlying mechanisms, began comparing Atlas's emissions to predicted fluctuations in the quantum vacuum, the restless background of space-time itself. The object's light signatures appeared to oscillate along frequencies that matched mathematical predictions of vacuum resonance, theoretical breathing of the fabric of reality. If Atlas had somehow tapped into these fluctuations, it might be drawing energy not from matter, but from the structure of space itself, using the sun as an amplifier. In effect, it could be using quantum field coherence to modulate stellar plasma, rewriting the very equation of energy transfer. This interpretation veered into territory where physics and philosophy began to merge. The idea that something could exist in a state between matter and field, between life and machine, began to surface in private discussions. The bioplasma theory emerged from these margins. The notion that Atlas could be a form of plasma-based intelligence, a living system composed of electromagnetic fields and quantum coherence rather than carbon and chemistry. Its behavior, synchronized pulses, thermal regulation, feedback coupling, aligned eerily well with definitions of self-maintenance and adaptation, hallmarks of living systems. But to call it alive was to cross a boundary. It demanded a redefinition of biology, consciousness, even existence itself. What is life when stripped of flesh and molecule, when it becomes pure information suspended in electromagnetic form? In this light, Atlas ceased to be a rock, or a machine, or even a construct. It became a mirror, reflecting humanity's deepest question. Can awareness exist without form? As this possibility took shape, the emotional undercurrent within the scientific world deepened. Many researchers, once grounded in mathematical certainty, began to feel unease. Their instruments returned data too elegant to dismiss, yet too alien to explain. Equations became approximations. Hypotheses turned to interpretations. They began to describe the phenomenon not as anomaly, but as orchestration, a pattern of coherence that transcended their models. One senior physicist described the experience during a private debrief. "We keep calling it chaos because our mathematics cannot predict it. But what if chaos is simply order beyond our comprehension?" Atlas, in its silent orbit, seemed to embody that sentiment, a fragment of intelligence or evolution, or accident, existing precisely at the boundary where science ends and mystery begins. The data continued to flow, precise, beautiful, defiant, and somewhere between the glowing sun and the cold of interstellar space, the line dividing discovery from revelation grew thinner, until they were no longer separate at all. As the months passed, the data surrounding Atlas reached a point of saturation. Every major observatory, from the European Space Agency's solar orbiter to Japan's Hinode mission, contributed terabytes of raw telemetry, each dataset pointing to the same conclusion. Atlas's activity was systematic, not stochastic. Patterns repeated with atomic precision. Its luminosity variations aligned with solar magnetic reconnections to within fractions of a second, while its thermal output maintained exact consistency. Despite temperature gradients that should have shattered any known material, such synchronization could not emerge from randomness. What unsettled researchers most was the consistency of Atlas's electromagnetic harmonics. Spectral decomposition showed that each pulse contained layered frequencies arranged in ratios, consistent with harmonic resonance models used in advanced communication systems. When analysts applied Fourier transformation to the dataset, they found nested repetitions, modulated bursts that encoded information density higher than any known natural emission. It wasn't speech, but it had structure. The discovery forced agencies to establish cross-laboratory task groups to rule out instrument contamination. Yet independent confirmations continued to arrive. The emissions were real, and their complexity implied design. At NASA's Goddard Space Flight Center, a team began mapping Atlas's field morphology using data from the solar probe's magnetometers. What emerged resembled a toroidal containment structure, a donut-shaped field encircling the object. Within this shell, energy flowed in smooth rotational symmetry, reversing polarity in controlled cycles. The behavior echoed electromagnetic confinement methods used in experimental fusion reactors on Earth, such as tokamak. But unlike those human designs, Atlas maintained perfect stability without apparent energy loss or turbulence. Its field reconfigured in response to solar pressure fluctuations, suggesting active compensation, the hallmark of feedback engineering. The anomaly deepened when thermal readings showed that Atlas's surface temperature was far below the predicted equilibrium. For an object so close to the Sun, in normal circumstances, such proximity should vaporize rock and metal in seconds. Yet Atlas remained intact, its temperature hovering at a stable range comparable to Mercury's night side. The only plausible explanation involved an internal mechanism regulating thermal exchange. Plasma physicists theorized that Atlas might be encased within an electromagnetic barrier capable of deflecting high-energy particles, effectively creating a localized zone of thermal isolation, a dynamic shield sustained by the object's own energy output. Attempts to simulate these conditions in laboratory settings repeatedly failed. Facilities such as CERN and the Max Planck Plasma Institute replicated the surrounding parameters within high-energy chambers, but none could reproduce the non-dissipative field behavior seen around Atlas. Every artificial model collapsed within microseconds. Theoretical physicists eventually suggested that Atlas's energy system operated through quantum coherence, a collective state in which particles act in synchronization across macroscopic scales. In this state, energy flow could bypass conventional thermodynamic limits, maintaining equilibrium by adjusting quantum phase relationships. It was an idea bordering on impossible physics, yet it remained the only hypothesis consistent with observation. When cross-spectrum analysis correlated Atlas's emissions with subtle variations in solar neutrino counts, the implications became even more profound. Neutrinos, nearly massless particles emitted in staggering quantities by the Sun, interact weakly with matter. Detecting any modulation within their flux implied influence at the level of nuclear fusion itself. The data hinted that Atlas's proximity coincided with small, periodic variations in neutrino emission rates, far too consistent to be statistical noise. Some concluded that Atlas was interacting directly with the Sun's fusion zones, possibly through resonance effects within its magnetic envelope. If true, it meant Atlas was operating at a depth of physics that bordered on stellar engineering. This hypothesis, that an object could interface with the Sun's core processes, unsettled even the most cautious scientists. Governments imposed communication restrictions on research teams to prevent public speculation. The official stance was that further analysis is required to confirm correlations. Yet within closed circles, the tone shifted from curiosity to caution. If Atlas truly affected stellar mechanics, its implications extended beyond science. It represented control over energy at scales humanity could barely quantify by mid-year. The combined efforts of international research programs produced one unified conclusion: Atlas did not fit any natural classification. It was not a comet, asteroid, or interstellar debris. It sustained stability, structured emission patterns, and energy coherence positioned it closer to a form of active system, something that operated by principle rather than coincidence. The question changed from what Atlas was to what it was doing. Some proposed that Atlas acted as a stabilizer, a mechanism preventing solar instability by redistributing magnetic and plasma energy. Others viewed it as a collector, an entity, harvesting the Sun's excess radiation for an unknown purpose. The most daring theories posited that Atlas was part of a broader cosmic process, a node within an energy-regulating network that spanned multiple stars, balancing stellar evolution across interstellar distances. Among the many data threads, one stood out. Atlas's field interactions occasionally produced signals within the microwave band, matching theoretical models of Hawking radiation leakage from quantum fields. To those versed in advanced cosmology, it hinted at an even deeper connection, that Atlas might not be merely manipulating energy, but using the Sun as a platform to manipulate space-time curvature itself. Quantum field resonance, energy redistribution, magnetic equilibrium, all could be components of a unified operation occurring on scales too vast for human comprehension. As the weight of evidence grew, the atmosphere within scientific institutions shifted toward reluctant awe. The datasets were irrefutable, yet interpretation demanded a language that did not yet exist. Physicists accustomed to deterministic frameworks found themselves describing Atlas with terms borrowed from systems biology and information theory. It behaved less like a machine and more like a process, self-correcting, energy-efficient, and adaptive. By the close of the observation cycle, the prevailing sentiment was not disbelief, but recognition that human understanding had reached its perimeter. The data continued to flow, silent and precise, while the Sun itself, a billion-year constant, began to exhibit small, but measurable rhythm changes that aligned perfectly with Atlas's orbit. For now, science could only measure. Understanding would have to wait. The object moved on, unhurried, as if aware that its purpose would reveal itself only when humanity was ready to interpret it. At first, the mainstream view held the ground. To most of the scientific community, Atlas was a mirage born from complexity, a misunderstood fragment of cosmic debris behaving in ways that only seemed intelligent, because the instruments watching it were too limited to see the full picture. Inside conference halls and review panels, the rationalists took control of the narrative. The first hypothesis, cometary feedback. Atlas, they said, was a remnant body venting volatile compounds as it interacted with the solar wind. Those releases, when ionized, could produce rhythmic bursts of electromagnetic activity that mimicked deliberate modulation. Its so-called glow, that persistent emerald radiance, could easily be the product of ionized oxygen and diatomic carbon. Under the immense ultraviolet exposure of the sun, green comas were not unprecedented. Comets had exhibited them before. Perhaps Atlas was simply doing so on a scale amplified by its interstellar composition. Still, the synchrony between its emissions and solar flares remained bothersome. Mainstream theorists turned to magnetohydrodynamics for answers. They proposed that the sun's magnetic field lines, twisting, folding, and snapping under the strain of plasma motion, could be amplifying Atlas's emissions. A coincidence of geometry, they said. The object might simply sit within a region of heightened resonance, turning the normal flicker of magnetic activity into apparent coordination. To the skeptic's eye, the data didn't imply intelligence. It implied interference. Another camp focused on the spectral evidence. Near the sun, light scatters through radiation fields so extreme that even a slight deviation in viewing angle could distort readings by orders of magnitude. Spectrometers aboard solar probes were not built to operate in such chaotic conditions. Radiation scattering could easily produce false signals, distortions that looked like modulation but were simply light bouncing unpredictably off charged particles. In other words, the mystery might be human-made, born from the limitations of observation itself. Electrostatic discharge offered yet another explanation. As Atlas rotated within the charged plasma environment of the heliosphere, its surface might accumulate static potential. Sudden discharges could create bursts of light and electromagnetic pulses. It would not be the first time this had been recorded. Similar behavior had been observed in asteroids passing through high-density plasma regions, where induced currents triggered transient auroras of their own. Perhaps Atlas's position near the sun simply magnified this familiar process to spectacular proportions. Engineers joined the debate, pointing not to physics but to calibration. Every instrument in orbit degrades over time. Thermal drift, sensor fatigue, and radiation damage gradually warp sensitivity. The Parker Solar Probe's magnetometers, operating in the fiercest radiation environment ever encountered, might be generating phantom signals through sensor interference. The rhythmic patterns could be an artifact, a shadow cast by the instruments themselves. Theories of coded emissions, they argued, relied too heavily on data unverified by redundant sensors. Until an independent platform observed the same signal, the pattern meant nothing. In closed meetings, these arguments were persuasive. Committees emphasized caution. Extraordinary claims demand extraordinary evidence. The phrase repeated like a mantra across agencies. History had already seen its share of cosmic illusions, Martian canals, pulsar signals, and phantom planets that vanished under better resolution. To many, Atlas was merely another chapter in that long story, a reminder of how human perception bends before the enormity of the cosmos. And yet, the evidence did not fade. The synchrony persisted. The emissions repeated with precision beyond any mechanical coincidence. Even after recalibrations and cross-verifications, the patterns held. Each data release, rather than dissolving the anomaly, refined it. The rational explanations began to feel brittle, consistent on paper, yet increasingly inconsistent with reality. By the time ESA's solar orbiter completed its fourth observation pass, the argument for natural causation weakened further. The observed fluctuations in solar plasma density did not align with normal solar wind turbulence. Instead, they corresponded to Atlas's positional geometry, its alignment with solar magnetic arcs. Statistical analysis by the Harvard-Smithsonian Center for Astrophysics revealed that the correlation probability was less than 1 in 100 million if the relationship were random. Such precision demanded reconsideration. Then came the neutrino data. Independent of all optical instruments, neutrino detectors on Earth and in orbit registered periodic modulations synchronous with Atlas's light pulses. These measurements could not be explained by reflection, scattering, or radiation artifacts. Neutrinos pass through matter unimpeded. Their modulation required real physical processes, alterations in the nuclear fusion dynamics of the Sun itself. This discovery alone undermined every naturalistic model proposed. In response, the defenders of orthodoxy revised their stance. If Atlas truly influenced the Sun, perhaps it was through indirect resonance, a feedback loop, they argued, between magnetic oscillations and internal solar dynamics. Not control, merely interference. The Sun's immense magnetic field could, in theory, resonate with a nearby conductor, amplifying its own oscillations. Atlas, then, could be acting as a mirror, not a manipulator, a coincidence of geometry and electromagnetism. But the deeper the models went, the less they aligned with the data. The modulation intervals matched prime number ratios, not random harmonics. The electromagnetic phase shifts occurred in ways that defied known plasma physics. Atlas's glow patterns changed ahead of solar events, not after them. Each new observation chipped away at the wall of skepticism, not through sensationalism, but through the quiet persistence of evidence that refused to vanish. By late analysis, even the most reserved voices conceded unease. If not artificial, Atlas represented a natural process completely outside existing theory. It was not behaving like matter should. The logic of its stability, the structure of its emissions, the precision of its timing, all implied design or, at the very least, intention. The mainstream view could no longer hold its ground without distortion. Each explanation stretched further until it began to sound less like science and more like avoidance. And so, the conversation shifted. The line between natural and constructed began to blur. The phrase, intelligent mechanism, entered scientific papers with cautious language, conditional, speculative, but present nonetheless. Something was guiding Atlas's behavior, or it operated by principles humanity did not yet understand. The rational world, grounded in evidence and skepticism, found itself approaching the edge of comprehension. The natural explanations, once safe, now looked fragile beside a deeper possibility that the object in question was not an anomaly of nature, but a product of purpose. Still, the rational camp pressed on. In their laboratories and control rooms, scientists leaned over streams of raw telemetry, seeking coherence within the noise. To them, the object's radiance, its strange synchronization with solar events, had to be a byproduct of known physics. Perhaps Atlas's orbit simply aligned with regions of fluctuating magnetic intensity. Perhaps its glow was nothing more than sunlight refracted through a cloud of charged particles, an elegant but ordinary play of plasma and field. Data models were recalibrated. Simulation environments were rebuilt from scratch. When the Parker Solar Probe transmitted its magnetic field maps, researchers noticed an odd overlap every time Atlas brightened. The Sun's local field intensity spiked in the same pattern. But in classical models, cause and effect should have flowed in the opposite direction. The Sun, unimaginably vast, should influence the fragment, not the reverse. Yet time and again, the graphs told the same story, Atlas pulsed first. The mainstream explanations stretched thinner with each cycle. Observers proposed delayed signal timing, an artifact of light travel distance or instrumental lag. But even after corrections, the phase alignment persisted. Others blamed cosmic rays interfering with sensors, though the pattern's precision made that improbable. The green emission remained stable at specific wavelengths, too consistent to be random noise. Laboratory plasma experiments using ionized nickel, silicon, and carbon failed to reproduce the hue or its energy ratio. On paper, it still resembled a comet, but its coma density was orders of magnitude too low to sustain visible luminescence for this long, especially so near the solar corona. The argument shifted from data interpretation to the reliability of instruments themselves. Were the solar imagers misreporting? Could the extreme radiation flux near the sun be distorting spectra? To test it, simulation teams fed the same parameters into independent radiative transfer models from multiple observatories. The results converged. The glow, the pulse, the electromagnetic coupling were all real. Whatever Atlas was doing, it was not a ghost of measurement. Mainstream science faced a quiet impasse. The rules held, but the phenomenon refused to fit within them. Peer reviewers urged caution, invoking Carl Sagan's timeless reminder that extraordinary claims demand extraordinary evidence. So, the data was held under intense scrutiny, frame by frame, wavelength by wavelength, and still, the image of Atlas remained uncooperative. It rotated without shedding debris, radiated without heat, and seemed immune to the sun's furious convection. Even in high-energy ultraviolet, where most comets dissolve in hours, Atlas maintained structural coherence. In closed sessions at NASA and ESA, internal reports softened their conclusions. Highly anomalous, one paper read, with unknown stabilizing mechanism. A European solar physicist proposed a magnetic resonance effect, the sun's immense field creating a standing wave that temporarily shielded the object. But the math fell apart when scaled to real solar conditions. Another suggestion involved electrostatic charging. Perhaps Atlas carried a surface potential so extreme that it generated its own miniature magnetosphere. That too failed, as the charge required would disintegrate any known material by the end of those months. Even the skeptics were running out of vocabulary. They no longer debated what Atlas was doing, only how it continued to do it. In the faint edge between certainty and disbelief, a few began to wonder if the sun itself was responding, subtly altering its own magnetic patterns as if engaged in feedback. For the first time, the mainstream scientific consensus began to fracture, not through conjecture, but through endurance. Every test designed to disprove Atlas's anomaly instead reinforced it. And so, the rational school was left with a paradox, an object that should not exist, performing actions that should not be possible, yet leaving traces that could not be denied. The universe had offered them an equation without balance, a phenomenon that asked for new physics. In the corridors of observatories and the dim light of mission control, a realization began to take hold. Perhaps the limits they defended so carefully were not the boundaries of truth, but only the edge of what their instruments could still describe. In the quiet corners of the astrophysical world, where data ends and imagination begins, the theories about Atlas began to take on a different color, no longer framed by the rules of chemistry or mechanics, but by the vast architecture of cosmic possibility. For the scientists who dared to wander beyond the edges of convention, Atlas was not an intruder, but a participant, a structure, perhaps even a being, engaged in a relationship with the sun too intricate for human instruments to resolve. This line of thought birthed what became known as the solar symbiosis theory. According to its adherents, Atlas was not feeding on the sun's plasma, but balancing it, damping the instability of its magnetic fields, the way a coral reef modulates the energy of an ocean wave. The synchronization between Atlas's luminous surges and the sun's magnetic oscillations was not coincidental. They argued but a feedback process, an ancient rhythm of exchange between matter and field, life and light in the archives of speculative physics. Another notion rose from obscurity, the ancient machine hypothesis. To some, Atlas's geometric symmetry and energy retention suggested construction, not coincidence. Its sustained coherence in regions where temperature and radiation should annihilate all structure hinted at material science beyond terrestrial understanding. Perhaps, they said, Atlas was a relic, a remnant of an extinct civilization whose mastery of stellar energy once surpassed human imagination. Like a drifting satellite from another epoch of the galaxy, it might have been designed to stabilize suns, harvest plasma, or transmit information through stellar mediums. Its glow could be a signature, its orbit a pattern, repeating across time as an echo of forgotten engineering. But even this mechanical interpretation could not contain the anomaly's strangeness. Quantum physicists began to discuss dimensional interaction. What if Atlas did not fully exist in our space? Some patterns in its emissions mirrored the frequency spread expected from hypothetical higher dimensional resonance, as if portions of the object flickered between phase states of reality itself. In that framework, Atlas could be extracting or exchanging energy through dimensions where conventional thermodynamics collapse, allowing it to remain cool even when enveloped by the sun's million-degree corona. The idea remained untestable, but it whispered to a deeper truth, that what appeared as physics might be the visible edge of geometry. Humanity had not yet mapped. Others took the idea further still. If Atlas displayed behavior that seemed adaptive, could it be more than a mechanism? The sentient probe concept proposed a staggering alternative, that Atlas was a self-replicating intelligence, born not of biology but of cosmic design. It might drift from star to star, communicating through light itself, using stellar activity as a language. Its glow, its pulses, even its silence could be structured, a form of information exchange so vast that it eludes recognition. If the universe is seeded with intelligence, perhaps this is how it speaks, not through words, but through the modulation of suns. And then, from the borderlands of philosophy and physics, emerged the cosmic garden hypothesis. It imagines stars not as isolated furnaces, but as nodes in a galactic web, living systems that breathe energy through magnetic filaments and quantum fields. In this view, Atlas was neither tool nor traveler, but caretaker, a gardener of light, maintaining balance across the cosmic network. Its purpose would not be conquest or observation, but continuity, ensuring that stellar chaos never overwhelms the fragile architectures of life scattered through the void. The image was at once haunting and serene, a stone of green fire tending to the heart of the sun. As these ideas took shape, the tone within the scientific community began to fracture. For some, it was exhilarating, the first hints that humanity might be witnessing a phenomenon that connects the mechanical and the metaphysical. For others, it was deeply unsettling. If Atlas was alive, or worse, aware, what did that make the sun? What did it make every star in the galaxy? Could life itself be the faint residue of processes that begin within the hearts of stars? In quiet conferences and late-night observatory sessions, these questions spread like whispered storms. The evidence remained the same: pulses, fields, emissions, yet interpretation had turned from data into revelation. If life began with sunlight, one researcher wrote in a private memo, perhaps consciousness too is stellar. That single line began to circulate across the network, reappearing in presentations, essays, and even classified mission notes. It blurred the line between science and something far older, the human impulse to seek meaning in the light that birthed it. As Atlas continued to orbit, unbothered by speculation or skepticism, the emotional landscape around it began to shift. Wonder deepened into reverence. Curiosity sharpened into unease. For the first time, the sun, once the most familiar star in human history, began to feel like part of a larger, exiving system whose boundaries extended far beyond human comprehension. The fear did not come from the idea that Atlas was dangerous, but from the dawning realization that it might not be alone. Silently, the debate began to evolve into something far greater than scientific rivalry. Governments convened closed-door meetings with leading astrophysicists, demanding clarity where there was none. Space agencies reclassified portions of the data from the Parker Solar Probe and the Solar and Heliospheric Observatory, citing instrument recalibration procedures, though insiders whispered of correlations too exact to be dismissed. The electromagnetic surges, once dismissed as measurement noise, appeared to follow deliberate timing intervals, harmonics aligned with solar flare decay cycles. It was as if Atlas were listening, responding, adjusting. The object's motion through the corona displayed improbable stability. Its orientation relative to the sun's magnetic poles was precise, even elegant. It seemed to resist random drift, holding position as though anchored by invisible logic. Among theoretical physicists, a small but growing faction began to frame the conversation not around what Atlas was, but why it existed. They revisited the forgotten archives of Freeman, Dyson, Nikolai Kardashev, and John von Neumann, minds who had once dared to imagine self-replicating systems spanning stars. Perhaps, they suggested, Atlas was not the whole, merely a fragment of a system too vast to observe from one vantage point, a single cell within a galactic organism maintaining the energy balance of its host stars. The idea was unsettling in its symmetry. If galaxies evolved mechanisms for stability, could intelligence itself be a natural consequence of cosmic thermodynamics, a process, not a miracle? Quantum theorists introduced even stranger considerations. When analyzing Atlas's radiative output, a few detected what they described as statistical entanglement signatures, patterns matching theoretical quantum coherence far beyond known scales. If accurate, it would imply that parts of Atlas were interacting instantaneously across immense distances, perhaps even across stars. It defied the inverse square law, bending light and field into something more akin to computation than combustion. These patterns were fleeting and unstable, but they suggested coherence across vast frequencies, like whispers from a mechanism designed to manipulate the quantum vacuum itself. Still, the mainstream dismissed such conclusions as premature, or worse, anthropomorphic. The universe, they argued, was not obliged to make sense to human intuition. Ionized gas and radiation could mimic intelligence in chaotic patterns. Perception, not reality, was the deceiver. Yet, quietly, even the skeptics admitted unease. Too many anomalies had aligned for coincidence. The trajectory shifts, the spectral coherence, the synchronization with solar activity, all mirrored coordination. When confronted with the full mosaic of evidence, one senior analyst muttered during a closed briefing, "Either we are missing a law of physics, or we are witnessing one being written." Cultural reactions spread faster than scientific consensus. Online groups formed digital cults around the green glowing visitor, calling it the solar messenger or the returning engineer. Religious leaders issued cautious statements, attempting to balance awe with doctrine. Ancient texts were reinterpreted to describe celestial emissaries maintaining the heavens. For millions, Atlas became proof, either of divine intention or of cosmic kinship, and through all this noise, the object remained silent, its emerald pulse undiminished, indifferent to interpretation. Meanwhile, in laboratories scattered across the world, small experiments attempted to reproduce its behavior. Plasma confinement rings, quantum vacuum chambers, and electromagnetic coils worked tirelessly, yet each attempt failed in the same way. The field decayed. No structure remained coherent. Whatever Atlas was doing to maintain integrity near the Sun, it defied replication. Its processes were self-contained, inaccessible. Even the strongest magnetic stabilizers collapsed under conditions that Atlas seemed to thrive in. The conclusion was quietly written into an internal NASA document. Energy persistence, unknown internal regulation implied. The deeper the investigation went, the more the anomaly became a mirror. Each theory reflected human expectation, mechanical, biological, divine, but none could fully explain the calm precision of its existence. As the data streams continued, one truth grew impossible to ignore. Atlas behaved as though it knew the Sun, as though its orbit and emissions were guided by intimate familiarity with stellar processes. Beyond current physics, it was this awareness, implied but never proven, that began to haunt those studying it. Not because it suggested life, but because it suggested purpose, a pattern that made sense only when viewed through a lens of intent. And in the quiet hours of simulation labs and control rooms, many who had once mocked such ideas began to wonder the same question that no paper dared to ask aloud. If Atlas is not random, if it is not inert, then what kind of universe creates something like it, and why did it choose now to be seen? In that silence, science and speculation merged. The object continued to orbit, the Sun continued to burn, and humanity, for all its equations, its telescopes, its restless need to define, could only watch. The mystery of Atlas had stopped being an astronomical question. It had become a philosophical threshold, a reflection of everything humanity still does not understand about consciousness, purpose, and the strange intelligence of the cosmos itself. The Atlas anomaly has moved beyond curiosity. It has become an era. Across continents, a silent alliance of observatories now watches the Sun with an attention once reserved for deep space. Every flicker, every spectral tremor, every rhythmic pulse is logged, dissected, and compared against the green signal that began it all. The network, an unprecedented fusion of public and private effort, operates under a singular mandate, continuity. Not a moment of Atlas's orbit is to go unobserved. Its glow has become the metronome of the modern sky, dictating schedules, budgets, and sleepless nights in glass-walled data centers. Machine learning, once a peripheral tool, now forms the backbone of analysis. Supercomputers trained on decades of solar data sift through trillions of data points, searching for order within chaos. What they find unsettles even their creators. The luminous fluctuations surrounding Atlas are not random. They follow harmonic ratios, familiar only to engineered systems, patterns resembling frequency modulation, pulse width control, even phase shifting. When plotted, the data forms coherent waves, almost musical in nature. Physicists describe it as controlled modulation, a feedback loop between Atlas and the solar environment. If true, it means Atlas is not merely reacting to the Sun, it may be communicating with it. This revelation has reignited the oldest debate in science, the boundary between natural law and intention. Research papers flood arXiv, each claiming a fragment of understanding. One suggests plasma resonance akin to magnetohydrodynamic coupling. Another proposes field synchronization between solar flux ropes and an artificially coherent magnetic bubble. Each study adds a thread to the expanding tapestry of speculation, yet none can explain the precision, the mechanical cadence of something that behaves like both a reactor and an organism. NASA, ESA, and JAXA, once cautious in their phrasing, now speak of Atlas not as an object but as a system. It is monitored through a new collaborative framework, the Solar Atlas Observation Grid, spanning heliophysics missions and Earth-based detectors. Data flows continuously into encrypted archives. Public datasets are heavily redacted, citing national research confidentiality. Officially, this secrecy is to prevent premature conclusions. Unofficially, it fuels an entire parallel ecosystem of doubt. Conspiracy forums and private channels teem with speculation that Atlas is rewriting solar activity, that it is terraforming energy output, that humanity's star is no longer fully its own. In 2027, the debate will move from observation to encounter. A fleet of autonomous CubeSats, launched under the Helios Edge initiative, will attempt to fly within 0.1 astronomical units of Atlas. Each satellite is equipped with hardened spectrometers, plasma sensors, and shielded communication arrays. Their mission is simple, an impossibly complex approach: observe, survive. The window will last only hours before solar intensity forces retreat or destruction. No human will be aboard. Yet, in a sense, all of humanity will be watching through their sensors. For the first time, instruments will cross the field boundary, the invisible perimeter of green radiation that surrounds Atlas like a magnetic halo. Meanwhile, the Sun itself behaves differently. Since Atlas's return, solar flares have dropped by nearly 30%. Coronal mass ejections, once unpredictable and violent, have softened into measured waves of release. Space weather forecasters note an unprecedented calm in the heliosphere. To engineers, it is a blessing. To scientists, an anomaly. The timing is too precise, the change too immediate. The possibility arises. Atlas is stabilizing the Sun. The alternative, more unsettling, it is rewriting its behavior. In government briefings, that phrase has become taboo. Rewriting the Sun implies agency, and agency implies consequence. If Atlas alters solar dynamics, even slightly, the ripple effects could reshape climate models, radiation belts, and long-term energy distribution across the solar system. It may extend the Sun's life, or shorten it. No simulation yet agrees on the outcome. The public, caught between fascination and fear, fractures along predictable lines. Some call Atlas a guardian, an interstellar caretaker preserving the balance of stellar life. Others see it as a parasite, drawing sustenance from a dying host. Social movements adopt new symbols: green suns, fractal halos, ancient sigils reinterpreted as prophecies of light. News anchors speak of Atlas with reverence normally reserved for celestial gods. A generation grows up knowing that a foreign intelligence, or something like it, now circles their star. Inside the scientific community, fatigue mixes with quiet awe. There is no precedent, no handbook for this kind of discovery. Every new observation expands knowledge while eroding comprehension. Researchers speak in paradoxes. Atlas is both stable and volatile, passive and responsive, inert and alive. It refuses classification. Even artificial intelligence, trained to model its emissions, begins producing outputs, labeled indeterminate consciousness signatures. The algorithms, designed to interpret radio signals, cannot decide whether they are decoding physics or language. In the end, one truth emerges, fragile yet undeniable. The more humanity studies Atlas, the less familiar its own science becomes. Equations blur at the edges, constants tremble into uncertainty. What began as a cometary anomaly has evolved into a mirror reflecting the limits of human understanding. The sun, that ancient symbol of constancy, now hosts an object that defies every category of known existence, and in that defiance lies the quiet transformation of an entire species. For perhaps the first time in history, humanity is forced to confront a reality that may not include it at the center, a universe not merely observed, but observing back. Atlas continues to orbit, steady, deliberate, indifferent. Its light persists across the black void, pulsing in measured rhythm, a question encoded in green, written into the solar wind, waiting for an answer that science has not yet learned how to ask. As observation deepens, the tone of inquiry shifts from confidence to unease. The patterns once assumed to be mathematical coincidences continue to persist across independent observation arrays. Datasets gathered by different institutions, NASA's Parker Solar Probe, ESA's Solar Orbiter, and India's Oddity L1 mission, display near-perfect synchronization in their recordings of electromagnetic resonance. The frequencies align not just with Atlas's own oscillations, but with secondary harmonics embedded in the solar magnetic field. The implication is uncomfortable. Atlas may not simply exist within the heliosphere. It may now be integrated into it. Attempts to decode Atlas's signal as communication yield inconclusive but provocative results. Radio telescopes detect low-frequency pulses that appear to carry phase-shifted harmonics, a technique used in advanced data encoding. Cross-correlation with solar flare timing reveals non-random relationships. Atlas's emissions precede certain solar changes by measurable intervals, ranging from seconds to minutes. It reacts before the sun does. That temporal offset raises an extraordinary question. Is Atlas predicting solar activity or controlling it? Inside research circles, competing factions form. One group insists that Atlas is a natural self-organizing plasma entity governed by emergent properties not yet understood. Another argues that its structural coherence, geometric symmetry, and energy modulation are incompatible with randomness.